Good morning, dear students. A warm welcome to all of you for our today's digital session for the subject Science and Technology Section A. In our previous session, we have completed with the different chemical reactions in chapter number 8, Metallurgy. We have studied about the chemical properties of metals and the chemical properties of non-metals. We have even started with the next topic, ionic compounds. Let us revise the ionic compounds part once again because it is a very important topic in this chapter, and then we will move towards the main theme of this chapter, metallurgy. In metallurgy, you are going to study the different terms related to it, and then we will move towards the basic principles of metallurgy, how pure metal is obtained from the ore by different stages. In that, the first stage is concentration of the ores. There are different methods which are involved, which are used for the concentration of ores. Each and every method we are going to look into today. So let us begin with ionic compounds. What is an ionic compound? How an ionic compound is formed, I need not tell you, because from the 9th standard you have studied the formation of sodium chloride, common salt, which is nothing but an ionic compound. Ionic compounds are nothing but the compounds which are formed from two units, that is the cation and anion. They are called as ionic compounds, a simple definition. The same example we will take for you to understand. Sodium, when it donates one electron, it forms a positive ion, whereas chlorine, which takes up that electron, forms a negatively charged ion. So when the compound is formed from the combination of both sodium and chlorine, where ions are formed, such a compound is called an ionic compound. Now, the cation and anion, one is positively charged, one is negatively charged. Both are oppositely charged, and hence there is an electrostatic force of attraction between them, and this force of attraction between the cation and anion is called as ionic bond. I hope you have understood what are ionic compounds, what is an ionic bond. In the previous standards also you have studied about this. Now, the number of cations and anion in a compound and the magnitude of the electric charge on them is such that the positive and negative charges, they balance each other, and so we can say that an ionic compound is electrically neutral. The number of cations and anion in the compound and the magnitude of electric charge on them is such that the positive and negative charges balance each other. If you are given plus 2 chocolates and then minus 2, plus 2 minus 2, no chocolates left with you. Okay, so you are neutral. There are no chocolates in your hand. So similarly here, an ionic compound, you can say, is neutral in nature. Now we will see its other properties. The first is ionic compounds are crystalline in nature. What do you mean by crystalline? Last year in the 9th standard, chapter number 13, carbon an important element, there you have studied about the crystalline allotropes. So crystalline means it is present in the form of crystals having definite arrangement of atoms. Now, if you see the surfaces of all the particles of a crystalline substance, they have a definite shape, they are smooth and shiny. If you take the example of common salt, the common salt which actually you get in the granular form in the market, not the powdered form, they are shiny. They have a definite shape, definite arrangement of atoms. Here, after definite shape, the regular arrangement of ions in the solid ionic compounds, that is mainly responsible for the crystalline nature. Now, the arrangement of ions, if you see, the positively, the negatively charged ions is different in different ionic compounds, and if you see, the shapes of their crystals are also different. So ionic compounds are available in the crystals of different shapes. Here different reasons can be asked. Now the main factor that determines the general arrangement of ions in a crystal is the attractive force between the oppositely charged ions and the repulsive force between similarly charged ions. Now, two of the important factors which are responsible for a certain crystal structure. The very first factor is the size of the positively and negatively charged ion. If you take the example of sodium chloride, sodium is the positively charged whereas chloride is the negatively charged ion. Second factor is the magnitude of the electric charge on the ions. Now if you see the electrostatic attraction in the neighboring ions with opposite charges is very strong, and hence we have seen that the melting points of ionic compounds are very high, and also the nature of this ionic compounds is they are very hard in nature and they are brittle. Now we will see the general properties of ionic compounds which are stated in the textbook. The first property is ionic compounds exist in the solid state and are hard. Just now I have told you that the attractive force between the positively and the negatively charged ions, that is the cations and anions which form that ionic compound, is strong, and this attractive force being very strong makes the ionic compounds very hard and when they exist in the solid state. Second is ionic compounds are brittle and can be broken into pieces when pressure is applied on them. Here I have stated melting and boiling points of ionic compounds are high. Why they are high? It can be a give reason. You know the intermolecular force of attraction is high in ionic compounds, and a large amount of energy here is required to overcome it, making the melting and boiling points of ionic compounds very high. The intermolecular force of attraction being high, you cannot easily break the bonds between them, and so the melting and boiling points of these compounds are very high. If you see about their solubility, ionic compounds are water soluble. Water soluble. This is because the water molecules orient in a particular manner around the ions separated by the process of dissociation, and as a result of this you will see a new force of attraction between the ion and the surrounding water molecules. Next, if you see about the solvents like petrol and kerosene, you will find that the ionic compounds are insoluble in the solvents. About the conduction of electricity, ionic compounds cannot conduct electricity in the solid state, but they can conduct it in fused or molten state. Cannot conduct electricity in solid state. Why not in the solid state? Because the ions cannot leave their places. Why they cannot leave their places? Because the intermolecular force of attraction is high. See how the concepts are linked with each other. And as the ions cannot leave their places, they cannot conduct electricity in the solid state. But what is the, you can say, reason that they conduct the electricity in fused or molten state? In this state, the ions become mobile. They start moving. The aqueous solutions of ionic compounds, they also conduct electricity as they contain the dissociated ions. In acid, bases and salts last year, we have studied about the process of dissociation. And on passing current through the solution, the ions move to the oppositely charged electrodes, the positively and the negatively charged electrodes, cathode, anode, and due to the electrical conductivity in fused and dissolved state, the ionic compounds are called electrolytes. With this, we complete with the revision of the topic ionic compounds. Now, our today's topic, we are going to begin the very important topic metallurgy. In the beginning, we are going to see the different terms related to metallurgy. What is meant by this term, metallurgy? It is the science and technology regarding the extraction of metals from ores and their purification for the use is called metallurgy. Now in the initial part, you will find different definitions related to metallurgy. You all know that most of the metals, being very reactive in nature, they do not occur in nature in free state but are found in the compound or the combined state as their salts, the different salts such as oxides, carbonates, sulfides, etc. But the most unreactive metals that remain unaffected by air, water and other natural factors like silver, gold, platinum, they are generally found in the free state. So, the next definition related to metallurgy is minerals, the compounds of metals that occur in nature along with the impurities are called as minerals. The compounds of the metals, I have told you that most of the metals they are found in the compound state, in the combined state. So that compounds of the metals that occur in the nature along with the impurities present in them are called as minerals. Our next definition is ores. Here you have seen extraction of metals from ores. What do you mean by this term ores? The minerals from which the metal can be separated economically are called as ores. This is the term which you have heard about it right from the lower standards. The next definition which we are going to deal with when it comes to metallurgy is gangue, or some call it as gang anyway. Now, ores, they contain many types of impurities such as soil, sand and rocky substances along with the metal compounds. These impurities are called as gangue. Now you know then when you are extracting metals from the ores will not contain only that particular metal in the compound state. It is found in the nature, so many other natural impurities like soil, sand, etc. will be present in it along with the metallic compounds, and these impurities are referred to as gangue. Now metals, they can be extracted from their ores by different means of various methods of separation, and the process of extraction of metal in pure state from the ores, it is also a part of metallurgy. Now, what is this entire process of metallurgy? Ores which are taken out from the mines and the gangue is usually separated from the ore. Gangue means impurities. It is all these processes are done at the site itself by using different methods, by using different techniques. Then the ores are carried out to the place where metals are produced from there. Metals are being, you can say, you get the metals over there, and these metals are further extracted in their pure form. Then the metals are further purified by different methods of purification, and this entire process is called as metallurgy. Now let us see the different principles of metallurgy. The basic principles of metallurgy. You know, you have to get the pure metal from the ore. So, which are the different steps involved in getting this pure metal from the ore? Now, the first principle of metallurgy is concentration of ores. The next is extraction of metals. Now, you have studied about the reactivity series of metals. Some metals are highly reactive, some are low reactive. So, this extraction is different for different metals. And then finally, refining of metals. That is the third stage. So, we begin with the first stage, that is concentration of ores. What do you mean by the term concentration of ores? What is this principle? The process of separating gangue means impurities from the ores is called concentration of ores, and in this process the concentration of the compound of the desired metal is increased. Now there are various ways, there are various methods which are used for this purpose. However, the exact way to be used, it depends on different things. The first is about the physical properties of the metal which are present in the ores and the impurities. Not only that, it also depends upon the reactivity of the metal and the facilities which are available at the site for the process of purification. Now there are various factors that could be responsible for environmental pollution. That factors also have to be taken into consideration. So now we are going to study some general methods which are used for the concentration of the ores. The first is separation, which is based on gravitation. The first method is separation, which is based on gravitation. What is the main technique over here? The heavy particles of the ores can be easily separated from the light particles of gangue by the gravitational method. Under this, you are going to study two methods. One is Wilfley table method and the other is hydraulic separation method. Wilfley table method. Look at the diagram which is placed over here. Now in this method of separation, this Wilfley table, it is made up of narrow and thin wooden rifles. This table, it is kept vibrating continuously. Powdered ore. Now the ore which you are having for the extraction of metal, that powdered ore which is obtained from the lumps of the ore by using the ball mill, it is poured on the table and a stream of water is also released from the upper side. See, powdered ore and then flushed by a stream of water which is released from the upper side. What happens over here? The lighter gangue particles, the lighter particles of impurities, they are carried away along with the flowing water, and hence you can see here it is placed in an inclined manner. The wooden rifles, they are on an inclined surface so that the flowing will become easier. So the lighter particles, they are carried away. What about the heavier particles? The heavier particles in which the proportion of minerals is more and the proportion of impurities, gangue, are less, they are blocked by the wooden rifles and get collected on the slits. You can see the slits in between them. So easily by this technique, in this method, that is the Wilfley table method, the lighter particles of gangue, they are separated, and whatever you require, that is the heavier metals that you get engaged in between the slits which are present, they are blocked by the wooden rifles and are collected on the slits between them. Now, the different questions which can be asked over here is a direct question. Write a short note on Wilfley table method, or draw a neat label diagram of Wilfley table method, or the diagram will be provided to you. You have to label the diagram, identify the method, and then explain about it. Our next method, which is based on gravitation, is hydraulic separation method. Hydraulic separation method, it is based on the working of a mill. So it is based on working of a mill. You know how a mill works. Now you can see here there is a tapering vessel similar to that which is used in a grinding mill. You take the wheat or rice to the grinding mill to grind it. So you have seen its structure. It opens in a tank-like container that is tapering towards the lower side. So this is the setup for the hydraulic separation method. Now here if you can see that tank, it has an outlet for water on the upper side and the water inlet on the lower side. So this is the structure. Now let us see how this method functions. Finely ground ore, it is released in the tank. You can see here powdered ore. Finely ground ore is released in the tank, and a forceful gel of water is introduced in the tank from the lower side. You can see this is the inlet for water. Now gangue particles are lighter and hence they will flow out along with the water jet from the outlet on the upper side. You can see gangue particles are lighter in weight and hence they will come out through this outlet on the upper side of the tank and they will get collected separately, and at the same time the heavy particles of the ore which you require, they are collected at the bottom from the lower side of the tank. And in this method, if you see in short, this method is based on the law of gravitation, wherein particles of the same size, they are separated by their weight according to the, or you can say with the help of water. So this is about the hydraulic separation method. Now both the methods you have studied which are based on gravitation. So in the exam the question can be asked, give the two separation methods based on gravitation for the concentration of the ore, or they will provide you with either of the diagrams, either the Wilfley table method or hydraulic separation method. Diagrams will be provided. You have to identify the method and you have to give the explanation, or a comprehensive type question can also be asked over here. Our next method after the separation based on gravitation is magnetic separation method. Look at the word. This method tells you that somewhere the magnetic properties come into play. Now this method, it requires an electromagnetic machine, and this method it has, or it includes two types of iron rollers and the conveyor belt moving continuously around them. You can see the conveyor belt which is moving continuously around them, and non-magnetic roller and magnetic roller. So the two types of iron rollers. One of the rollers is non-magnetic, other is magnetic. How does this method work? Now the conveyor belt which is continuously moving around the rollers, this conveyor belt, it is made up of either leather or brass. Powdered ore, it is poured on the conveyor belt near the non-magnetic roller. This is the non-magnetic roller. From here the powdered ore is put or poured on the conveyor belt near the non-magnetic roller. Two collector vessels are placed below the magnetic roller. This is the magnetic roller and these two collector vessels are placed right below them. Next, if you see, in this case, the particles of the non-magnetic part in the ore that are not attracted towards the magnetic roller. Now, in your ore, the particles which are non-magnetic, they will not be attracted towards the magnetic roller, and hence they are carried further along the belt and fall in the collector vessel which is placed away from the magnetic roller. This is the magnetic roller. Non-magnetic particles, they will be collected in the collector which is away from the magnetic roller. And what happens at the same time? The particles of the magnetic ingredients of the ores, they stick to the magnetic roller and therefore they fall in the collector vessel which is near your magnetic roller. So easily here you can see the separation, and in this way the magnetic and non-magnetic ingredients in the ore, they can be separated depending on their magnetic nature. If you take an example, cassiterite is a tin ore. It contains mainly the non-magnetic ingredient, that is stannic oxide, SnO2, and the magnetic ingredient ferrous tungstate, and these are separated by the electromagnetic method or the magnetic separation method. After the magnetic separation method, the next method which we are going to study is froth flotation method. Now this froth flotation method, it is based on two opposite properties, hydrophilic and hydrophobic of the particles. What do you mean by these terms, hydrophilic and hydrophobic? Hydrophilic means the substances which are attracted towards water. On the other hand, hydrophobic, phobia means you run away from that thing. So the substances which repel water, they are called as hydrophobic. Now here the particles of the metal sulfides, due to the hydrophobic property, they get wetted mainly with oil, while due to the hydrophilic property, see both the opposite properties are here, the gangue particles get wetted with water, and by using these properties, certain ores are concentrated by froth flotation method. How does this method work? Now in this method, if you see, finely ground ore is put in a big tank containing ample amount of water. This is the tank containing ample amount of water. Inside that you are going to put finely ground ore. Then certain vegetable oil such as pine oil or eucalyptus oil, it is added in the water for the formation of froth. You know what is froth? When you soak the clothes in soap water and you just try to penetrate that clothes in the water by making them immerse properly, then whatever gathers on the top is the froth, and hence for the formation of froth here different vegetable oils are used. Then pressurized air is blown through the water. There is an agitator rotating around its axis in the center of the flotation tank. You have seen how mother prepares buttermilk and separates the cream from the curds which are allowed to set in the refrigerator. She uses the agitator and keeps on agitating the mixture. After some time you will see the cream in the form of froth, it will gather on the top, whereas your buttermilk will settle at the bottom. So similar technique is used over here. The agitator here is used as per the requirement. Bubbles are formed due to the blown air, and due to continuous agitation, a foam is formed from oil, water and air bubbles together. This foam, it is lighter, so rises to the surface of the water and starts floating, and hence this method is called as froth flotation method. Now particles of certain sulfide ore, they float with the foam on the water as they get wetted by the oil, and hence this method is used for the concentration of zinc, blende and copper pyrite. So this is one of the methods which is used as a separation method, and the last method in our syllabus is leaching. Look at the term leaching. Now the first step in the extraction of certain metals like aluminium, gold, silver from their ores is the method of leaching. In this chapter you are going to study about the extraction of aluminium in details. How does this method work? Ore is soaked in a certain solution for a long time. Then the ore, it dissolves in that solution due to a specific chemical reaction. But the impurities in the form of gangue, they does not react and therefore does not dissolve in that solution, and easily they can be separated. Now, as I have told you, in this chapter you are going to study about extraction of aluminium, and I have told you here the first step in the extraction of certain metals like aluminium, gold, silver. So concentration of bauxite, which is the aluminium ore, it is done by this method, that is leaching method. Here this bauxite is soaked in the aqueous NaOH, that is sodium hydroxide, or aqueous sodium carbonate, which dissolves the main ingredient alumina in it, and then gangue can be separated differently. Today we have seen the different methods which are used for concentration of the ores. As I have told you, the basic principles of metallurgy, that is how to obtain pure metal from the ore, includes different stages. The first stage was concentration of the ores, wherein you have seen many methods which started from Wilfley table method, hydraulic separation method, magnetic separation method, froth flotation method, and leaching. Our next topic that we are going to start in the next session will be the next principle or the next stage in obtaining the pure metal from the ore, and that stage is extraction of metals. Now, extraction of metals you are going to study for three different types of metals: reactive, moderately reactive, and less reactive. And then final stage will be refining of the, you can say, whatever metal you want. So refining of that metals is the final stage. So in our next session, we are going to study about the extraction of metals and refining. Not only that, we are going to study about extraction of one of the metals, that is aluminium. And our last topic that will be also taken up, corrosion and the different methods to prevent corrosion. So I request all of you, before you attend the next session, kindly go through all these topics, because most of the part here is theoretical. You have to learn, you have to memorize the things. So the more you read, the more things will be registered in your minds. Thank you, dear children.